good content uh, since you're all making an effort to be here. So this is Google Cloud for the ColdFusion community. And I hope everybody can see my screen. Um, my name is Terry Ryan. I'm a developer advocate for Google Cloud. At present, I work for Google as a developer advocate for Cloud. Before I joined Google in 2014, and I joined as a cloud developer with a focus on application development. Before that, I was a Flash platform evangelist for Adobe with a focus on ColdFusion. So some of you may remember me from my days there. And I joined Adobe in 2009. Before that, I had worked in higher ed as a ColdFusion administrator. So a lot of my ColdFusion knowledge is still there, although it's rusty. And so I'll kind of talk you through what I did to sort of make sure I could have stuff to show you today. So agenda, I will be talking about Google Cloud from a web developer's point of view, right? I'm not going to be, I should say that I've kind of limited it to a set of Google Cloud products that make sense to talk to this particular community. I won't be talking about all of Google Cloud. Google Cloud has a incredibly large number of products under the umbrella of Google Cloud. Things ranging from VMs and databases, which I will be talking about today, to big data analysis tools, to machine learning models and automatic machine learning models, and basically stuff that is a little bit beyond my area of expertise, right? So it's a wide range of things, so I won't be talking about all of it. The other thing I won't be talking about is ColdFusion plans for Google Cloud. I know that there are plans afoot of integrating better support for Google Cloud into ColdFusion, the main product. But I do not have any information beyond what has been announced or has been said publicly about this. And there's a reason for that. Like I don't want to accidentally, violate an NDA or anything. So I've tried very hard to not absorb plans, other than that there's going to be, from what I understand, like the way that AWS and Azure is integrated into current versions of ColdFusion, you're going to see some of the same options for Google Cloud in the future. So, I have crap. Have I ever said how much I absolutely hate Google Slides? Yep, I said it. I have lost my slides, and now I can't get them back. So hold on a sec while I dig through and try to get back. You know what? I'll outsmart it. All right, there we go. All right. Okay, so normally I would spend some time polling you and trying to get from you kind of some information that kind of help guide me talk to you. I know it's a little awkward in this format, so trying to think. I tell you what, I'm going to make some assumptions, and if anybody violently protests these assumptions, please feel free to at me in the chat for the session. So I am assuming that most people here are working with ColdFusion in some sort of VM environment. That you're not currently, there's not a lot of activity going on containerized ColdFusion on Kubernetes, ColdFusion on some sort of container serverless application. That for the most part, your ColdFusion environments are going to look like a VM connected to a database, and that could be on the cloud, that could be in your own data, your own server room, but that's the kind of environment we're looking at. If that is not the case, I'm happy to go into ColdFusion on containers and some of our containerized technology, but that'll be more off the cuff than prepared. So okay, so let's kind of start. Like I said, I have been rusty with ColdFusion. So one of the first things I did when I went to prep for this talk to talk at the ColdFusion Summit was build an application in ColdFusion. It's been a while, and I figured, might as well go ahead and do that. And I've found the experience to be a lot of fun because it's been a while since I've written any CFML. So I wrote a super original demonstration application, a to-do app. And you'll see its UI is up at the top left here, and it's all based on using ColdFusion ORM. And the actual application itself did not take a tremendous amount of time to write, owing to ColdFusion's productivity features. It took me a little while to stand up the ColdFusion server, and if people have questions about that, I'm happy to go into that later. But yeah, so it's just a kind of silly little, to-do app. But in building that app, I was able to kind of implement this kind of infrastructure, right? So we've got a ColdFusion app server running on a virtual machine. It is connected to a database for storage, and then it's also connected to a cache for additional storage, right? So what this means in terms of Google Cloud is this, right? So for our app server, we use Compute Engine, which is our VM technology. I'll talk a little bit more about that in a second. I was running Ubuntu and ColdFusion 2021. Database, I'm connected to a product that we call Cloud SQL, which is our managed SQL installation, using MySQL for that. And then for the cache, I'm using Cloud Memory Store, again, our managed cloud storage for Redis. All of this is set up on a private network, and you'll see that there's a combination of the VM kind of lives on the edge of the private network, and it can also communicate with the rest of the world. But all the communication between clouds, between the SQL and the caching and the application server are all happening on a private network that I've set up. Additionally, I have wired together a secret manager, which makes sure that I'm not injecting passwords and the such directly in the application.cfm or CFC. That we're pulling these out in real time and using it dynamically. All right. So let me talk about Compute Engine. Compute Engine is our VM technology. It is our version of EC2 is probably the easiest way of describing it, but it's not something I'll ever write down lest our marketing people get on me. But that's, if you're looking for EC2, Google's version of EC2, it's Compute Engine. You can configure machines from from a shared with 4 other machine core, right? A quarter of a core to 416 cores. Memory anywhere from 614 megabytes to 11.5 terabytes. Disks, we have standard disks, SSD, hybrid. We have attached SSD for really fast throughput. And you can arrange these in anywhere from 10 gigabytes all the way up to 257 terabytes. In addition, you have the ability to add GPUs. You have the ability to add TPUs. TPUs are tensor processing units. GPUs are graphical processing units. Both of these are used in kind of advanced computation and mathematics. But TPUs are specifically geared towards machine learning training. So if you're doing certain tasks with TensorFlow or other ML model trainings, TPUs might get you better performance. So this is one of those things where I like to just spin up a VM and kind of show you what this is all about. So I'm gonna go ahead and I'm gonna show you our Compute Engine VMs. So here is the VM I currently have already set up. It's all ready to go, but I'm gonna go ahead and create an instance because I think this is really impactful to show you actually running in the thing. So I'm gonna make sure I give it a name like delete me, so I remember to delete it. It's region. You'll see that I have a number of regions that I can pick from, and I also get information on how they are with CO2 emissions. And I have a number of zones in each region that I can use. Again, all of this is for redundancy and whatnot. Say machine configurations, right? I have a number of machine configurations, and they vary from location to location, but they pretty much all describe a certain set of processor architecture, right? E2 versus N2. They're a particular set of architectures there. And I have some options for, do I want a general purpose? Do I want to compute optimize? Do I want memory optimized? Do I want GPUs? And I can even, let's see, customize them and build custom CPU shapes, right? So if I want, I don't have to do, look at these numbers, right? We've got 2, 4, 8, 16, 32. But if I really needed 24, I could customize and build that out specifically. So I can really shape my work to the size of the job I'm doing. Let's see, what else can I show off here? Boot disk, I can go through and change, right? And I have my operating systems. I have my choices of operating systems, including Windows Server, because there's some people are surprised that we have Windows on, but yeah, we're equal opportunity. We're happy to work with Windows as well as various flavors of Linux. I can go through. I can set it as a balanced persistent disk or SSD persistent or standard persistent. Right, I have a whole bunch of options here, and I can compare the disk types and see exactly what they do different. But I'm just going to go ahead and pick the basics. And I'm going to go ahead and create this. All right, so this is creating. And what I like to say is that these take tens of seconds to spin up. And what I mean by that is like when no one is watching and I'm just doing it for my own self, it takes 10 to 20 seconds. When people are watching, it takes 40 to 50. I don't know how it knows. It just does. But no. So that one was really it. I guess if virtual meetings don't count. So this is one of my favorite features of our VMs is the fact that they're just very easy to get into. You'll see that there's a little button that says SSH. I go ahead and I went ahead and clicked it. It's doing some work to transfer the SSH keys to the VMs. We may have changed security models for my account. So hold on. If not, that's really frustrating. One of the joys of being a Google employee is that our security setup for Google Cloud is a layer of security on top of the standard security, and for us it's almost always onerous. But there we go. I got it. See, I just had to click the other thing, and we'll see that here I am SSH'd into machine. I can go ahead and start running administrative tasks on it, but I can see, here I am on this machine, and yeah. So getting into and interacting with these machines is really, really easy. Now I could also run remote commands on it via CLI, but in any case, thank you for the vote of confidence there, Jim. Yeah, so I can really easily get into these things and start, doing what I need to do on the machine, and like I own it from a very early in the process of installing. All right, so that was our VMs. So let me talk about a couple other features that are available that are usually things that people are interested in and want. So I showed you one machine. Typically, when you're doing a production environment, you have multiple machines, right? So we have this thing called managed instance groups, where basically you create a machine type and some parameters for scaling, and we can either auto scale or you can scale depending on the parameters you set up, right? And you can set limits, right? You can say, so I want no less than 3, but no more than 20, and we'll honor that. And you say, like, as load goes up, spin up the number of machines, right? So as the load goes up on those machines, it'll spin up more nodes. And you say something like, I want these machines to be 80% utilized or 50% utilized or whatever. And when those thresholds get surpassed, that's when we spin up extra machines. Or when we drop below those thresholds, we'll drop machines. Again, all that's configurable by you. Now, what you'll do is you'll take one of these and you'll slap a load balancer on the front of it, so that you can you can have one endpoint for them. All that's configurable and relatively easy to work with. Disk imaging, so you can build your own images. So you can, like, in case of something I would do is I would build a locked down ColdFusion production server on a disk image that is built to my project or company's needs, and then just reuse that over and over again. Instead of pulling down in the beginning, when I pulled down a Debian image, I would pull down a custom, this project image. You also do snapshots, which are time and place captures of the information on disks, so you can use that as part of a backup strategy. Logging and monitoring are also all integrated in, and if I have time, I will show the logging and monitoring. But all of that comes kind of wired together and ready for you to use kind of right from the get-go. So that's all of that was stuff that, like, you kind of expect and is sort of standard, and you kind of, it's table stakes for VM technology. But I want to talk about a couple of things that we have that are slightly different than the rest of the industry and helpful to see. First one being preemptible VMs. You may be familiar with Amazon has a concept called spot instances. This is, I think, occupies some of the same space, but is not by any stretch the same setup. The way preemptible VMs work is that you have a hard set. This will cost usually around 20% of the actual, like, the full cost of the VM. But it will only last for a maximum of 24 hours, and it can go down at any point within the next 24 hours. And so this is really great for batch work, for work that is running in a queue. You can just take these cheaper VMs and put them in the queue and have them kind of whittle away at the queue. It's important to note that, like, just because you lose a VM doesn't mean you can't re-request a VM. It's just you lost that particular one. So you can set up managed instance groups that spin up preemptible VMs, and when one dies, another one will be spun up. So this is a way of us. The reason we offer them is because it allows us to increase the utilization of our network when usage is perhaps not at its highest. Then it allows you to get a cheaper price while no one is requesting that machine. The next feature is live migration, which is a really cool thing. So under the covers, when we do updates on the hardware and infrastructure that your VMs are running on, we can do that without causing you downtime through this process called live migration. And what we do is we take your VM, we basically clone it somewhere else. We duplicate the memory between the two, we sync them up, and then we cut over. And we cut over the memory and cut over the networking. And so the visible experience of it is that if these machines won't go down, there's no downtime for them. There is a slight network, I wouldn't say hiccup, it's more of a latency, more of a lag, right? Like, you'll be having a response at a very quick rate, and then it'll slow down for a little bit and then speed back up as the new network pieces take over. But what this allows is, like, when we have 0-day exploits, for example, there's been a couple of them at the processor level. We've been able to patch large amounts of our customers without them experiencing any amount of downtime. Now, this is a feature that you can opt out of, and that's why I say a large amount of our customers, not all of them. There are some reasons why maybe you would not want this happening under the covers, but for most use cases, live migration is just a great way of, like, we never affect you in terms of maintenance. So that's a pretty cool thing. And then I'll talk about this in a second. One of the other things that powers all of this is the Google network. So Google Cloud uses the same infrastructure for Google Cloud that it uses for Google Search and all the rest of our products. So you get to take advantage of the network that we have built for ourselves to power Google. It's not a separate thing. It's not, so when we make things better for us, we make things better for you as well. And so first thing this means is that we are able to offer Google Cloud in a large number of regions and locations. And these numbers, we're constantly spinning up new ones, and you'll see there's even some ones on here that are not that are in the process of building out, that are coming soon. And to back all this up, we have our own infrastructure. We have our own fiber that we run, and so we actually there are some great stories come out of this work. But basically, we have ships that drop the wire to run it around the world. And one of the more interesting things is because of this, we now know internally as a company that it is possible for you to have an outage because a shark ate your network connection, because that literally happened to us. A shark bit on one of these fiber optic cables that caused outage, which is perhaps one of the coolest, I guess not for the customers that had that problem. I'm sure it didn't make it any easier for them to deal with the fact that they had an outage, but what are you going to do? A shark bit your network cable. All right, so kind of moving on from the VMs and the infrastructure technology, I want to kind of talk about some of the other pieces of this. So I brought up Cloud SQL, which is our fully managed SQL provider. Right now, we provide MySQL, Postgres, and MySQL server. MS SQL server. And you can go up to 624 gigs of RAM and 96 CPUs. You do up to 64 terabytes of storage are available. And one of the cooler things we have about our platform is that you can dynamically and automatically resize. So you can build your SQL servers to have minimal disk. And as the needs for disk grow, it can automatically resize without downtime to accommodate the size of your data. One of the other things, Jim, so I see your question, which is the new Albany data center in Ohio is up and running now or still in the build process. I do not know off the top of my head. I will drop my email at the end of this talk. I highly recommend you drop me an email, and I will find that answer for you. Okay, so Secret Manager. One of the things I talked about is, like the days of dropping passwords into application.cfc files should be over. This is generally not a good way of doing things, especially with people pushing things on GitHub and whatnot. And so secret management tools are something that people have been taking advantage of. HashiCorp has Vault. I know there are comparable services on Amazon. We have Secret Manager. It's pretty simple. It's a key value pair. It's encrypted, and then you can inject it into other services relatively easily. Now, in order to work with it from ColdFusion, I need to make SDK calls. Now, unfortunately, there is no ColdFusion SDK for Google Cloud, but there is a Java SDK for Google Cloud, and so I'm able to use Java features in ColdFusion to make that happen. I ended up using yeah, so here I'm using native object loading for ColdFusion for Java. So I just threw in the jar files, made sure they were available, and I'm able to go through and use the Java SDK in order to make calls from ColdFusion to get this. And so this is how I get ColdFusion secrets from Google Cloud secrets from ColdFusion. Now, one of the things that I do here is I pass in a project. I'm going to talk a little bit about projects in a second, but it's important to know, how can I get this information from ColdFusion? How can I figure out what project I'm running on? And you'll see here I have a different function. This one is using HTTP service to get at our metadata. Each project has metadata that will, with a URL call from a VM to a network that is only available on that VM, will give it information like the project ID. All right. So project. Everything in GCP happens in the context of a project. I kind of alluded to a little bit to that, and I can pop over to I might pop over. I think my next slide is me popping over to the interface and showing it off. What's important to note is that networking within a project is global. This is one of my favorite features of the way we do things, is that when I go and set up machines, I don't have to wire them together. I don't have to set up, I can, but I don't have to set up VPCs and other networking pieces to have them talk to one another. By default, all the machines are on the same network, and they can easily address and communicate and be connected to one another, which makes kind of setting up stuff really, really easy. I don't have to worry. I don't have to think of my resources in terms of data centers. I think of them in terms of a project that these devices all have as a feature what data center they're in. And then, like I said, project resources can span zones and regions. So real quick, let me hop into, so this is, this was the project I set up for before, ColdFusion Demo 2. We'll go back to the head of it, and let's see that I can see the dashboard. Is that it? Yeah, the dashboard, and I can see all kind of my resources at a glance. One of my favorite pieces that is relatively new, so I don't always remember where it is asset inventory. So I can see a list of every single resource that I've spun up. So this is my environment that I spun up for here, and we can see that I have a couple networking routes, some firewall rules, some secrets, some versions of secrets, some compute disks, images, network, logging buckets, and whatnot. And so I can see all my resources in one spot, which is really helpful. And I can go through and interact with them however I need to. All right, I'm gonna switch back. All right. I briefly touched on memory store, that we have a managed Redis service that I was using for my caching layer. I can use Redis or Memcache, and its integration with other products and networking. The Kung, how to map ColdFusion data source to Cloud SQL. Relatively straightforward. You have an IP address, and you just plug it in to the data source structure, either in the administrator or in your application.cfc. But it's just an IP address, username, password, yada yada. All right, so here's my environment up to now. How did I go about building all this infrastructure? I used Terraform. I don't know if how many people are familiar with Terraform. When I gave this talk at the summit, there was not it was not 100% buy-in on Terraform, so I figure I will at least talk about it a little bit more. So to build your infrastructure, you have two choices, two major choices. You can do other stuff. You can write your own API calls if you wanted to, but for the most part, most people build their infrastructure by using either the gcloud CLI or Terraform. So gcloud CLI allows you to kind of roll your own solution, write whatever bash scripts or other shell scripts that you want. Typically, they're updated with the latest alpha and beta features pretty much immediately, and they get the latest product updates. It's very easy to mix code tasks with infrastructure tasks because they're just bash scripts, and you can write multiple bash scripts, and you can include other executables and other things. Relatively easy. And for the most part, gcloud CLI can do any management task that you need on Google Cloud. And so I contrast that with Terraform, which is a more industry standard way of managing things, right? Like you can write Terraform scripts that'll manage Google Cloud or Amazon or Azure, and it all uses the same language and the same kind of description to build all this stuff. It's got built-in dependency management, right? So if you need to plug in the name of the database instance into somewhere else, it will note that and will spin up the database server first before it uses the name somewhere else, right? So it does really good dependency management. It's repeatable, right? The whole purpose of it is that you're not necessarily saying sequentially build these things. You're saying this is what I want my environment to look like. So when you run Terraform, it's going to make your environment look like the Terraform script was asking for. So if you've gone through and changed things, it will sometimes muck those up. So you want to do all your management through Terraform. But yeah. The only thing is that it is designed for infrastructure and not necessarily for code. Those are supposed to be separate processes. Typically, you want your infrastructure built one way, and then you want your code kind of delivered via CI/CD. So Terraform kind of has that bias built into it. It's very kind of kludgy to do like the initial put the first set of code into the application. It is kind of kludgy to do that with Terraform because kind of philosophically they probably don't want you doing it with it. So here's how I create a Google Cloud VM instance. Let's see, gcloud compute instances create. And one of the things I have to do to complement our team that builds this SDK is that this stuff is super predictable. So if I want to spin up a database server, it's going to be gcloud SQL instances create. If I want to set up a new serverless service, it would be gcloud run services create, right? Like there's the API is they've done a really good job. I didn't work on that team, so I can compliment them. It's not me, supporting my own work, but they did a really good job of making the API for the CLI like super predictable. All right, and then this is how it looks in Terraform, right? You set up a resource and you set up all those things and say, I want this, and Terraform makes it happen for you. So there are a couple pieces that weren't necessarily obvious on this. So the first one is cloud storage. I do that for storing some stuff to transfer it around, which brings up what is cloud storage. Cloud storage is our blob storage. It's basically, I have it written here, operates like other industry solutions in the space. Like that's weasel words for it's our version of S3. The interface is very similar. It's used a lot of the same way, and that's what it is. Now, it's important to note that cloud storage occupies sort of a middleman space in Google Cloud as well. In addition to just being standard blob storage, um, a lot of times when you need to transfer information from one service to another, you'll put it in cloud storage, and that's kind of the easiest way for those services to get at it. So if I extracted data from BigQuery and then wanted to run an AI model on it, I would write it to cloud storage and then tell the ML product to read it there. And that's how we communicate for things like blob storage or documents, text, images, videos, and binaries. We also have a technology called PubSub, which does a lot of messaging communication. So I just want little messages back and forth between various parts of my apps. PubSub is pretty much the way to go. For example, if I want to manage costs, if I want to say set up a billing notice that whenever X number of dollars is spent, I would like to have that set to some code to do something. I would set up a PubSub channel. The updates about the billing will go into the PubSub channels, and whatever subscribers I have listening to them will react to them. So there are the two ways of talking between our services, are either cloud storage or PubSub. Okay, so one last piece that I didn't have here, which is Cloud Build. Cloud Build is our CI/CD platform. Allows you to build and publish. And you can do anything you can do in a container, you can do it in build. So let me kind of show what I'm doing here. So here I have, this is the Cloud Build configuration file, and you'll see it has steps. These are the various things it did. So I'll just kind of try to walk you through this. I did gcloud compute SCP to copy a whole bunch of code files over to the server. And then I do gcloud SSH to go through and copy them from one place to another using sudo. And then I do the same thing and copy another bunch of files, right? So even though Cloud Build has this reputation of being like it's for containers, you don't have to do things for containers with it. You'll see I'm just using it to be a repeatable build for various gcloud tasks. So, yep. All right. So, and then all of that is triggered off of GitHub. So anytime I make changes to the code, it's going to go ahead and run that publishing step to basically take the code from the GitHub repo and copy it over to the VM. So now here's my entire environment, right? Using Terraform to build it. It's based off of changes I make to GitHub. GitHub will trigger an automatic build that updates the code. And all of this is to service the users of my crazy, incredible to-do app. All right. So, so that ends kind of all the work I did for working, kind of getting ColdFusion up and running in an existing environment to be able to talk about what would be important. But there are some other tools of note on Google Cloud that I think would be of interest to you all. The first one is Cloud Run, which is basically a serverless container solution. You write a container, as long as it listens on port 8080, we can run it for you and scale it to as many or as little users as you want. It can scale down to 0. So when it's not getting used, you don't get charged for it. There's integration with Secret Manager and Cloud SQL and Memory Store to make it all work well. Now, here's where I have to be honest and tell you that I could not get the ColdFusion container image running on Cloud Run. There are some security restrictions that ColdFusion is making some calls that Cloud Run didn't like. That being said, I know there's work being done in that space to make that happen. And I will say this very carefully. While you cannot get Adobe's CFML engine running on Cloud Run, you can get other CFML engines running on Cloud Run. And that I can confirm works. All right, Cloud Functions. So Cloud Functions, it would be a lot of work to write ColdFusion and run it in the Java runtime. Um, obviously, these days, all of us are using more languages than just ColdFusion, if nothing else, JavaScript, because we generally need to have some sort of JavaScript calls. So what Cloud Functions are event-driven calls. It's I think analogous to Lambda is the technology on Amazon side. Um, so these are event-driven functions. So storage events, someone writing something to a storage bucket. PubSub, which I talked about earlier, is a communication platform, or just you can write them so they answer HTTP calls, but they're meant to be small, bite-sized function as a service offerings. And then again, probably you'd end up doing something in Node or Java, depending on what languages that you're comfortable with. Developer tools. So one thing I didn't really show off was Cloud Shell and Cloud Shell Editor. I'm thinking I have enough time. I'm going to just go ahead and pop over here. And so here is my project from before. I'm going to launch Cloud Shell. Cloud Shell is a little VM that has all of the runtime tools needed to work with Google Cloud Project. So the G-Cloud tools for dealing with cloud storage, Kubernetes-based tools, Terraform, and then runtimes for all the languages that we support. And so basically, and this little workstation stores a home directory for you that gets attached to this every single time. And so, if I want to run gcloud big we run a successful command. Okay. All right. So the gcloud tools are enabled, and I can even let's see here. Where is the open editor? You'll see that it switches modes, and instead of being just an SSH session, will actually be an in-browser VS Code instance, where I can go through and make changes and kind of use this in combination with the terminal that runs in VS Code to do things, right? So, and that's all built in. And all ready to go for you as soon as you connect. All right. Yep. Did a quick demo of that. So now questions we get like, how do I migrate? Well, we do a lot of work with lift and shift workloads. There's a couple different products, one of which is called Valstrata, which will actually kind of duplicate your VMs on Compute Engine, but everybody's environment is different, and there is no clear one path to go from where you're at to running on Google Cloud. So I highly recommend you look at our migration pages, which will talk about how to do that. If you are doing big enough migrations, you can engage our sales and post-sales teams to help with that. So I don't work in that space, so I know very little about migrating you over, and that's a salesy thing and not a developer advocate thing. So I don't know that much about it. Compliance offerings. One of the big questions I get, especially with all of our government employees that tend to be, ColdFusion tends to have a big presence in government. We do offer a fair amount of compliance, and I can't list them all off the top of my head, but we do have a page. You go cloud.google.com/compliance. You should get to this page where you can go through and actually see what regions, what zones, what industries, what compliances we have to offer. It's important to note that when we say things are compliant, for the most part, it means you are capable of building we have been certified that you can build a compliant offering on top of our infrastructure. However, It doesn't guarantee that it's compliant, right? Because the application can be out of compliance even though the infrastructure is compliant. All right. So conclusions. There's a lot, right? There is, I didn't touch on a lot of our various bits and pieces of our platform, right? I didn't talk about big data at all. I didn't talk about ML jobs at all. I talked a little bit about storage and our compute offerings. Didn't even get into kind of advanced networking stuff. There's just a lot of Google Cloud, and it's more than one person can do in 1 hour to talk about it all. It is though. We do have a number of trial options, right? You can get started for free in addition to getting $300 of free credits that last for a year, I think, for new customers. There are also a fair number of products that have a free tier. So if you spin up a micro instance VM and never spin up another VM, you won't get charged for it. So you'll see that on this page, which is, I believe, cloud.google.com/free. This is our free offerings, and you'll see that there are thresholds for all of our products. Not all of our products, but many of our products, that if you use less than a certain amount, whatever you're doing is free. All right. I'd asked to keep in touch. I'm going to break for questions in a second, but I'll point out that if you want to get in touch with me, my Twitter handle is tpryan, and that is also my email address at Google. So anybody has a question for me that I ask you to research, that I say that I need to research and you need to get back to me, just email me at tpryan@google.com. All of the code and infrastructure configuration stuff for this project is available at GitHub/tpryan Google Cloud ColdFusion demo. So you may just want to look that up. But that's available for you, and that has the Terraform scripts, the code I used. Feel free to give me a code review and tell me how out of date my ColdFusion is. But yeah. So with that, I'll say any questions, and I'm kind of open to a whole bunch of them. I hope I answered your question on how to map ColdFusion data source to Cloud SQL. Basically, you know what? I'll just kind of show real quick. If I go to, let's see here. I go to databases, SQL. I'm going to close this interface, and you'll see here's my SQL server. You'll see that I get all the connection strings that you would normally use. I got a private IP address. There are some cases for some of our products where you need this connection name instead of the IP address, but for the most part, it's just a SQL server, and you can connect to it the way you normally would. All right. So any other questions? For costs, could you stage a dev and test environment, spin up when needed, if not on 100%, and a dedicated QA team, and then kill it and save the money for the time it's not up? You absolutely can do that. Any one of our VMs, if you spin down, you don't get charged for it. You still get charged for storage, right? Because you're taking up disk space, but it's pennies compared to the dollars, depending on their VM size. Yeah, absolutely could do that. You also could not just spin up and pull down an environment, but you could do it all on preemptible hardware, so you'd get even less cost to your stage and dev environments. So yeah, you absolutely can do that, Jim. And Terraform can script the whole thing. Yep. So Terraform, you can choose preemptible hardware. So yep, Terraform can handle all of that. So yeah, See, there's a little bit of typing going on, so I'm going to wait. Thanks. Oh, thank you, Jim. I hope it was worth getting up at 4 a.m. That makes me happy. Thank you very much, John. All right. Well, like I said, I see some typings going on, so I'll hold on. Yep. I will happily look it up. All right. Well, if there are no more questions, I'm gonna let it go once, let it go twice, let it go 3 times, and then say thank you all for showing up. And like I said, if you have questions and you have questions down the road, feel free to keep my email on hand. And yeah, it was really fun. Like I had spent so much of my time in my early career working in ColdFusion. It was really great to reconnect with it, and there is so much that is. I forgot just how enjoyable and easy it was to write stuff in ColdFusion, right? Like the actual code is so like with ORM and everything, it was just so easy to write. The simple to do app, but like it's it's easily under 100 lines of code for the back end, right? Because all that stuff is set up for you automatically. So it was a lot of fun. Really appreciate the opportunity, and thank you, Porva, for inviting me to talk to y'all. And with that, I'm gonna sign off. And thanks everyone.